Hello and welcome to part 5 of the ChessTDD series. To start off, I'm going to pull up the issues list that I had from last time, and I'm going to pull some things out. It's not really all that important to me to see what it was that I got done last time. It's kind of nice for reference, but I like to kind of start off with sort of a clean slate, so to speak, except for the things that need to be done, and then kind of add to this as I go in each individual session. So anyway, back to the IDE and picking up where we left off. All the visual settings are now kind of agreed upon and everything, and I think we're at a good place to start. So the first thing I'm doing here is I noticed that I'm in one place I'd made a big deal of using this board coordinate class, and I see that there's a place here where I'm not actually using it, so I am going to play a little with the font and whatnot here, and then hopefully not get too sidetracked by trying to keep track of the actual issue at hand, which is that get moves from in the rook class does not use the board coordinate type. So I'm going to mark that yellow, and then I'm going to move on and actually get that implemented. So the first thing to do here in order to make this happen is to go and find a test that I can make fail. So the way to make this fail is simply to pass a board coordinate. And I'll do that by adding parentheses around it and then passing in a new board coordinate. And once I do that, this test will fail by virtue of non-compiling, which, as we've discussed in the past, is a perfectly valid way to have a test fail. So it's also a nice, easy thing for TDD, and the simplest possible way to get this to pass is you make it compile. So I'll replace these two parameters with a single parameter called board coordinate, and I'll call this starting location. And then luckily I haven't done anything in the body of the method that's going to require any refactoring, so I'll get rid of the old. Now I have a new problem, which is that I'm going to have compiler errors in other places because I'm inheriting from piece, which is defining this abstract method get moves from, and we haven't updated the signature there. So what I'm going to need to do is go into the piece class and change this signature. Now that's going to have a chain reaction kind of effect because there's still the pawn class. Pawn class is going to have the old signature, so we're going to have to go in here and change it. And now that's also going to involve a bit of refactoring since this method is actually using the parameters in question. So I'm going to go and replace this. And what you're seeing is one of the first examples in this series of something that's a non-trivial way to get a failing test to pass in the sense of going and doing a lot of housekeeping in various places. And this will happen at times. Because remember, you're doing the simplest possible thing to get the test passing well. The simplest thing in this case, unfortunately, isn't that simple. There's kind of a tip of the iceberg thing going on. Sometimes that just happens and you have to go with it. So as you can see now, this has even dragged into a unit test. And this is a lesson to kind of take away. That's okay. If in order to get it passing, once you've created the initial failing test, you're refactoring, well, that's the wrong term to use, your changing of the signatures and everything, if that leads you into a test class, so be it. What we need to do is get to the point where we're making this test pass. So now I have all green. One thing I'm noticing in here is there's a lot of duplication. Anytime you have to go in and make a bunch of the same changes in different methods, that's kind of a smell. So rather than figure that out at the moment while I'm still trying to tease out an implementation and make sure all the tests are passing, I'm just going to make note of it and come back to it later. So now I've successfully got this method going in terms of taking a board coordinate parameter, so I'm happy with that. And one other thing I'm noticing now that this test is passing is that the assert is a little cluttered, so for readability, I'm going to pull this return value out of here. I'm going to introduce a local. And this is going to be the actual moves, and I'm going to assert that the moves count is 0. I like that a little better. It's a little more readable to me, and we can do that. We can refactor a test for readability now that the test is passing and everything is green. So having done that, now it's time to see what's next on the docket. So we can cross off get moves from not using board coordinate for the rook class, or in general, I should say. That's done. So now I have a bit of a design decision to make, which is I need to actually think about what it is that get moves from is going to do for rook, because rook is defined by just the general scope of wherever it can go on the board, which means it probably needs to know something about the board size. I don't want it to know anything about the actual board because that creates a design problem I had alluded in an earlier version of this to not wanting to do. I want the rook not to know anything, or any of the pieces to know anything about the board, but they might need to know something about board size. So what I'm doing is creating a failing version of this now that takes this parameter for the board size. And I'm going to say that just to get this going, I'm not going to change the test at all. I'm going to define this overload of the method. And I'm going to say if we pass in a starting location and also a board size, now what we're going to have to do to get this passing is get rid of this old method and replace it with a new one. And this is going to require going through the same song and dance as before. So when I look at this, oh, right, so object does not have a count method, so I have to go back and make this an IEnumerable. And while I'm at it, I'm just probably going to go in and make the changes that are necessary here. So there go my, there's red. I've got red, so I need to go make this pass. And the way I can do that is by having it not throw this not implemented exception. So I'm going to take this and I'm going to paste it into the newly defined method just to get this going green. And now I have it green. So next step is to think about what would I actually like this to do. So what I'll do now is perform a refactoring of sorts, and I'm sort of maybe fuzzing the boundaries a little, but I consider this to be kind of a refactoring. I don't know of a test I could write that isn't extremely weird to facilitate the removal of a method. So what I'm going to do is treat this as a refactoring wherein I go and I add this integer parameter to the rest of these methods. So I'm going to put this int in here and then do what's necessary to get it passing in other places. This is probably not, strictly speaking, exactly test-driven development by the book. And, you know, I've left this in here instead of kind of rethinking how I might frame this, what kind of weird test I could come up with to do parameter removal. And instead of doing that, I thought I'd demonstrate that sometimes you think about things in sort of a pragmatic way, especially if you're getting up to speed with the practice and you're not necessarily an expert at it and you have to get production code done. What I would encourage you to do if you are kind of making exceptions and fudging is go back a little and do some deliberate practice afterwards. Like maybe spend 15 minutes at the end of the day saying, okay, I needed to get stuff done, but how would I have approached this if I were really sticking to the letter of the rules? Because sticking to the letter of the rules is what gets the discipline to be sort of automatic in your head so that you can go through it. But I am nothing if not a pragmatist. There are times where you need to get things done. There are times where, you know, following the rules exactly doesn't always make sense. And to me, this was one of those times, and I thought I'd leave it in as something to talk about. So now I've gotten the refactoring done. That wasn't too bad. And I'm back to now figuring out what it is that I would like this method to do. I don't want it to return an empty collection anymore. So what would I actually like it to do when I start at 1-1 and give it a board size of 8, what should this be returning? So rather than tackle all at once exactly what moves a rook has, I'm going to say that if I'm at 1-1, it's going to return 7 vertical moves for me, meaning that I can move from 1-1 to 1-2, 1-3, 1-4, etc. And so what I'm going to do is I'm going to assert that this count is going to be equal to 7. And not specifically the count of all moves, but the count of moves where the x coordinate here is going to be 1. So I want to say that count of moves where x coordinate is 1 should be 7. And then I'm going to go and I'm going to do something over in the production class in order to make this pass. So what's the best way to go about getting this to pass? Clearly, returning an empty enumerable is not going to do it. One might say I could just return enumerable dot or create any enumerable with a count of 7, I'm going to go to a slightly more sophisticated implementation here, where I'm going to cycle through and I'm going to do something using yield return, which I've covered a bit before, is a way of just returning things one at a time in terms of deferred execution. So what I'm going to do is I'm going to say that if the index is not equal to the starting location's x coordinate, then I'm going to yield return, which is going to give me a way of describing what I want to return, a board coordinate, and the board coordinate is going to have the index and the starting location, and that should give me a total of 7 items. Now, what I'm doing here is maybe not exactly the simplest possible thing per se, but I think it's the simplest non-obtuse thing to do, in my opinion, and that's sort of a matter of some discretion that takes some getting used to and is really kind of subjective. Now, what's going on here is perhaps you've noticed I've made sort of a stupid mistake, and I've left in my mild bit of floundering is going to come with the debugger here. Basically, what I've done is transposed what should be returned in board coordinate, where it should be the starting location x coordinate and index, but it took me a little while to figure that out. I left this in part because I wanted to talk about something that's happening here, which is the trade-off I've made to say, okay, I don't just want to return, 7 board coordinates that I hand create that do what I'm saying. I want to kind of actually build towards my algorithm. The danger you run in doing that is the kind of floundering you're seeing here that interrupts your flow. So if I had just iterated through by hand and returned 7 board coordinates with an x value of 1 and a y value 2 through 8, then I would be in better shape of moving on and building on a good base. But I bit off a little bit than it turns out I was able to chew here right away. And so that really is the trade-off. You risk interrupting your flow versus you risk maybe being a little too laborious if everything's too simple. And also on the side of too simple at times, you risk not making any actual progress in terms of your test-driven development. For instance, if you're just hard-coding every possible conditional input in, you're not making progress. And there's some good literature out there, particularly from Bob Martin, about how to actually make progress and not just sort of infinitely implement the next obtuse conditional or what have you. So the takeaway from this, and you're going to see in a minute, I'll figure out what's going on, but the takeaway from this is you've got to find kind of a sweet spot in terms of what you view as the simplest possible thing you could do. Too simple and it's laborious, not simple enough, and you start to kind of struggle and do too much and suffer from a very micro form of big upfront design. I made a mistake, perhaps a little bit along these lines in this method. I'll get it corrected here shortly, and then we can move on. But the basic idea here is that I've got to, make these corrections accordingly. And what I really want to do is make sure that I'm returning the same x coordinate all the time and then iterating through the y. And now that I've done that, the test goes green. The to list I put in is sort of a debugger test is unnecessary. Later we'll come back and take that out. But finally, we can move on and figure out the next thing we want to do here, which is to say the same thing about the 7 horizontal moves. So just as the rook, which moves in straight lines on the chessboard, we should return all of the available vertical moves from that position. Same thing with horizontal. So what I'm going to do is I'm going to sort of laboriously here write the same instantiation logic, and I'm going to make a mental note that I want to fix that later. That's a little redundant. So I want to say get moves from, and I want to declare a new board coordinate. And you'll notice that this is also redundant. New board coordinate 118, same input as before. And now we're going to assert that the count of moves here is 7. And we're just going to flip the condition. We're going to say 7 where the board coordinate's y coordinate is equal to 1. So this is a very similar test. And here I'm going to leave off the to list because I don't believe that's actually necessary. And we'll just go with count here. And that's going to fail at first. But we're going to have to go back over to production and do the simplest possible thing to make the test pass. Now, I'm going to go back with a loop, but I feel a little bit better about this being the simplest thing because this time around I have sort of a blueprint to go off of, and I think that I can probably manage this time just by mentally looking at the area above it and transposing. So I'm going to say that it's not equal to the starting location's x value. I'm going to yield return a new board coordinate with the index this time, kind of like what I did last time. And now I'm expecting this to go green. And yield return, it doesn't have to be just one statement. You can have yield returns throughout the method if you like. So now I'm going to make note of some of these things on the actual to-do list. I'm going to say that there's some duplicate logic I didn't like in the test class, and then I'm going to talk about that there's some duplication of loops in the production class as well. So I'm going to move things around a little bit, group them in a way that I see fit here, and I'm going to make note of those items. So I'm going to make note of another thing here too that I had forgotten to mention a minute ago, which is zero indexing here is kind of what I've defaulted to as a programmer, but that doesn't make a lot of sense since we're indexing the actual chess moves in the problem domain. They don't do zero indexing there, it's 1 through 8. And then I'm going to say that there's duplication in the test and in the method for get moves, and that's the rook get moves that I'm talking about, even though I didn't necessarily notate it. I'm also going to move a couple of things over here that I think I'm not going to worry about in the nearer term future. I might focus more on breadth coming up and getting more pieces going. Now that I've defined this board size as being part of the arguments for a piece, I think it's going to be easier to go and do things like rook and knight. So I'm going to start out writing the next test here. And what I'm going to test in this case is I want to say that this get moves from method is going to return no moves that contain a zero index, and this is the failing test I'm going to create to sort of check that bit about getting rid of the zero indexing off. This is an easy hook I have for a failing test. I can just assert that nothing coming back has a x coordinate or a y coordinate of 0. So notice again, there's a lot of duplication, the same things I mentioned last time. Duplicating the board coordinate, duplicating the board size. So I want to assert that the count of moves where the board coordinate has an x coordinate of 0 or a y coordinate of 0, that I want that count to be 0. And then I got to go and fix my spurious trailing comma here in order to get it passing. Or I should say compiling. It's not going to pass initially. And to be perfectly honest with you, I'm not sure why it was so hard for me to figure out that that trailing comma was there. It's sometimes sort of embarrassing to watch yourself in retrospect, but after a bit of struggling, it looks like I figured out the commas and parentheses, and I can move on to more important things. So what I'm going to need to do is just change these guys to 1, and then this to less than or equal to in order to make the counts jive. And this should go green. And there's another item to cross off the list, so we're now moving away from the zero indexing phenomenon. So I'm going to mark this as green in order to mark progress. Looks like I'm going to miss at first and now mark it as green. So let's maybe take a look at some of this duplication that we have in here now, and I'll go over a couple of techniques you've probably seen me use so far, and you're certainly going to see me use a lot again. I'm going to create this property called target. And I'm going to create instantiation logic that's run before each test, so named before each test, and I'm going to use this test initialize method. This is set up for all the tests. Test initialize method is run before each and every test. So I'm going to say incorrectly that rook equals new rook. I meant target, but I was getting a little ahead of myself there. I started actually calling it target correctly in the methods down here, and I'm kind of moving on without even seeing that the method above isn't compiling, but no worries, it'll get fixed. And what I'm doing here is having this nested class inherit from the outer class. This is what allows it to access this private property. And there it looks like I figured out the compiling error. And you see the the dots go green and before each test once that's actually running. So now this is happening in each place. And I've eliminated the instantiation logic duplication, which I'm happy about. Another thing I'm going to do here is I see I have an extremely common input for all of my tests thus far. So I'm going to create a variable that I'm going to use over and over again that I'm going to call bottom corner. I think this promotes test readability and it eliminates the duplication. So I'm going to declare that const, and I don't remember if board coordinate is a struct or not, or if I'm going to be allowed to do that. I'll give it a shot. If not, it'll be a static read only. And then I'm going to declare this board size to be 8. And I'm going to substitute these things that I've declared for the magic numbers. Usually that's a good practice to substitute descriptive constant names for magic numbers. And it's also going to help me eliminate duplication if later I decide I want a different default board size. There we go. This cannot actually be a constant, so I'm going to say private read only. And I guess maybe I didn't declare that static. I don't remember off the top. At any rate, when I figure out what I want to declare it, I'm going to go and replace the logic of new board coordinate 1, 1 everywhere with bottom corner. And at least in my opinion, default coordinate, I guess I like that better. And there we go with the static. So I want to say, and I think this gets pretty readable actually, and especially more so I kind of have the same taste of myself. I like default coordinates. So get the moves from the default coordinate with the default board size. There should be this count. To me, this is kind of getting away from all the numbers and everything and telling a more compelling story here. That if I get moves from this default coordinate using the default board size, the following ought to be true. So now I've eliminated partially what I came here to eliminate, but then I think I noticed that I didn't do it in the production method. So this all looks suspiciously similar. And anytime I see code that's very similar like this in structure, I start to think that there's probably something we can do to improve the design and cut down on the duplication, and that's certainly true here. So what I'm going to do while everything is green is implement a refactoring. And the reason I do that while everything is green is because if you're trying to refactor when everything's red, you don't really know if things are getting redder or less red or what. You're starting out from broken and you're not really sure where you're going. But if you're starting out with everything's green, as soon as you start to see red, you know that your refactoring is actually not a refactoring and you're changing behavior. So that is the reason that I'm starting this refactoring with everything green. And what I'm basically doing is instead of having 2 loops, I'm just going to have 1. I'm not sure if this is the greatest implementation just yet, but it has eliminated the big piece of duplication that I saw, which is the iterating twice over the same exact kind of loop sequence. And I have a compiler error that, again, I embarrassingly didn't notice. So I'm going to delete this and then try to figure out why the code isn't actually compiling. I see black. This isn't covered by unit tests, but the reason for that is the non-compiling, which, right, it's a capitalization error. And even with that clue, even with what I want being highlighted, it took me a minute to figure it out. But I'm operating on faith here that eventually I did, got this straightened out, and then changed it from lowercase to uppercase X, and there I see my green dots. So I'm pretty happy about that. So in the end, I've eliminated duplication both in the test class and in the production class, and that's always good. And it gives me something I can go back and check off of my spreadsheet here, and then maybe wrap up by thinking a bit about what we want to do next time around. So I'm going to mark this green, and when I think about rook's get moves from being stupid or not, I'm going to mark it a lighter yellow because I don't think it's stupid anymore, but I think there's still work to do. And I'm going to call it a wrap from there, and I will see you next time.